Flow rate problems. The measurement of water flow rates is an important part of efficient water supply operations. Flow rate information is used in determining chemical dosages, assessing the cost of treatment, evaluating the plant efficiency, determining the amounts of water used by various commercial and industrial sources, and planning for future expansion of the treatment facility and its distribution system. Two types of flow rates are important in water supply operations. One, instantaneous flow rates at a particular moment. And two, average flow rates, the average of the instantaneous flow rates over a given period of time, such as a day. Instantaneous flow rates are calculated based on the cross-sectional area and velocity of water in a channel or pipe. Average flow rates are calculated from records of instantaneous flow rates or from records of time and total volume. Flow rates in water supply operations are measured by various metering devices such as weirs or Parshall flumes for open channel flow and Venturi or orifice meters for closed conduit flow. Instantaneous flow rate calculations. The flow rate of water through a channel or pipe at a particular moment depend on the cross-sectional area and the velocity of the water moving through it. The relationship is stated mathematically as follows. Q equals AV, where Q equals flow rate, A equals area, V equals velocity. Figure 217A illustrates the Q equals AV equation as it pertains to flow in an open channel. Since flow rate and velocity must be expressed for the same unit of time, the flow rate in the open channel is expressed as follows. Flow rate Q, flow rate cubic feet per time equals A, width, length in feet, by V, velocity, feet per time. In using the Q equals AV equation, the time units given for the velocity must match the time units for cubic feet flow rate. For example, if the velocity is expressed as feet per second, then the resulting flow rate must be expressed as cubic feet per second. If the velocity is expressed as feet per minute, then the resulting flow rate must be expressed as cubic feet per minute. And if the velocity is expressed as feet per day, then the resulting flow rate must be expressed as cubic feet per day. Figures 217b through 217d illustrate this concept. Using the Q equals AV equation, if you know the cross-sectional area of the water in the channel, the width and depth of the rectangle, and you know the velocity, then you will be able to calculate the flow rate. This approach to flow rate calculations can be used if the problem involves an open channel flow with a rectangular cross-section as shown previously, or if the problem involves a pipe flow with a circular cross-section as shown in figure 217E. Only the calculation of the cross-sectional area will differ. If a circular pipe is flowing full, as it will be in most situations in water supply and treatment, the resulting flow rate is expressed as follows. Q equals AV. Flow rate in cubic feet per time equals 0.785 by the square of the diameter, square feet, by velocity in feet per time, or flow rate in cubic feet per time equals 0.785 by the square of diameter in square feet by the velocity in feet per time. As in the case of the rectangular channel, if the velocity is expressed as feet per second, the resulting flow rate must be expressed as cubic feet per second. If the velocity is expressed as feet per minute, then the resulting flow rate must be expressed as cubic feet per minute. If the velocity is expressed as feet per day, then the resulting flow rate must be expressed as cubic feet per day. Example 43. A 15-inch diameter pipe is flowing full. What is the gallons per minute flow rate in the pipe if the velocity is 110 feet per minute? To use the Q equals AV equation, the diameter and velocity terms should be expressed using feet. Therefore, convert the 15-inch diameter to feet, such that 15 inches over 12 inches per foot equals 1.25 feet. 1.25 feet. Now use the Q equals AV equation to calculate the flow rate. Since the velocity is expressed in feet per minute, first calculate the cubic feet per minute flow rate, then convert to gallons per minute, such that Q equals AV, or flow rate equals 0.785 by the square of diameter by velocity, which equals 0.785 by 1.25 feet by 1.25 feet by 110 feet per minute, which equals 134.92 cubic feet per minute. Convert cubic feet per minute to gallons per minute such that 134.92 cubic feet per minute multiplied by 7.48 gallons per cubic feet equals 1009 GPM, 1009 gallons per minute. Example 44. A 305 millimeter diameter pipe flowing full is carrying 35 liters per second. What is the velocity of the water in meters per second through the pipe? You are asked to determine the velocity, V, given the flow rate, Q, and diameter. Note first that the diameter of 305 millimeters is equivalent to 0.305 meters. To use the Q equals AV formula to calculate velocity in a pipe, you should use the following mathematical step. Q equals AV, or flow rate equals 0.785 by square of diameter by velocity. Since you want to know velocity in meters per second, the flow rate must also be expressed in terms of meters and seconds, cubic meters per second. The information given in the problem expresses the flow rate as liters per second. Therefore, the flow rate must be converted to cubic meters per second before you begin the Q equals AV calculation, such that 35 liters per second multiplied by 0.001 cubic meters per liter equals 0.035 cubic meters per second. Now, determine the velocity using the Q equals AV equation, such that Q equals AV, or 0.035 cubic meters per second equals 0.785 by 0.305 meters squared by X, or 0.035 cubic meters per second equals 0.785 by 0.305 meters by 0.305 meters by X. And then solve for the unknown value, X, which is our velocity, such that 0.035 cubic meters per second over 0.785 by the square of 0.305 meters equals X, or 0.48 meters per second equals X, or X being the velocity equals 0.48 meters per second.